Welcome, geometry students, to Unit 1.5, Segment and Angle Bisectors. You're hearing the voice of Mr. May. I will be walking you through this particular lesson. As always, please make sure that you have your guided notes readily available. We will be completing those. And without further ado, let's begin. Our learning targets. Learning target number 1, I can define line segments based on points and distance along a line. Once again, we're going to be able to use points and a distance in order to define a particular line segment. Once again, we are seeing our use of vocabulary words, this time in our learning targets. Secondly, I can find the point that divides a segment into a given ratio. And so we're going to look at a particular point in a particular ratio, and that is going to involve using the midpoint formula. Like the distance formula, the midpoint formula is a set formula that you will have to be able to use in order to divide a segment into a given ratio. Excuse me, and I can define, lastly, I can define an angle based on points and lines. So once again, you have to be able to use the terminology in order to further the definition of, in this case, angle, but you can see how understanding previous terminology and previous vocabulary words is essential to building on each unit, building on each unit and further defining new terms and terminology. So bisectors. So when we look at bisectors, the first thing that I want to, in this case, literally highlight is bi. Now when we talk about bi, we see bicycle. Think about a bicycle. How many wheels does a bicycle have? It has 2 wheels. So anytime that you see this in reference to geometry, and actually in other areas of vocabulary, think 2. And so now we have 2 sectors, and kind of like segments, we can think of sectors as parts. So we're going to divide something into 2 parts. Now specifically, we're going to first divide a segment into 2 parts, a segment bisector. If you are unfamiliar with a segment, you can see the difficulty in furthering the vocabulary and your understanding of it. And so it is essential that you maintain your vocabulary throughout all the units. So let's look at the definition of a segment bisector. Segment bisector. So a point or segment, ray, or line, now it could be any of these. It could be a point, it could be a segment, it could be a ray, or it could be a line. Any of these could act as a bisector, okay? They could be the bisector. But it's what these point, segment, ray, or lines do that determines whether it will become or be classified as a bisector. And what it must do is it must actually divide a segment, okay? And why does it have to divide a segment? Well, let's look back at our term that we're defining here. It's a segment bisector. So we have to be dividing a segment. And we're going to divide a segment into 2. And why 2? Well, here we go. 2 refers to 2, which refers to bi in bisector, okay? So 2. Lastly, another vocabulary word, which we have to be extremely familiar with, congruent. Congruent meaning same segments. So if we have a point, segment, ray, or line that divides a segment into 2 congruent or equal segments, then we will say that it bisects or divides, okay, bisects the segment or divides the segment in general, but more specifically into two congruent segments, okay? I'm going to draw this because there was a lot that went into that. So if I have a segment, I have to start with a segment. Reason being, we're working with segment bisectors. So here's my segment. I'm going to call this segment AB. Now the definition says that I have a point, so I'm going to use a point. Now this green point, I could just as easily make it a segment, array, or a line. I'm going to use a point because that's the first word in the definition that we're working with. This point, I'm just going to call it point X, okay? So what we need to know is that if point X divides the entire segment AB into two equal segments or congruent segments, so if AX, and let's use our terminology, so if AX, and it's a segment, and recall the symbol for congruent, remember that is congruent, that is the symbol for it. If that is congruent to XB, proper notation, then we can say that X is my bisector and it bisects the segment AB. Okay? Furthering that, the point of bisection we actually call the midpoint. Now that makes sense. It's in the middle. X is in the middle of A and B. We call it the mid. X is a point, midpoint. Moving on to angle bisector. You may already be able to determine what an angle bisector would be just given the definition of segment bisector and parsing out the words. But let's go through it a little bit more specifically. First of all, I have to have an angle. So if I have an angle and I have points on this angle, let's call, and don't want to do that. Let's go with points X, Y, and Z that are on my angle. And so I have, using terminology, angle X, Y, Z. And then I have a ray. This is specific. You have to have a ray that divides the angle, okay? A ray must do. You can't have a point, you can't have a segment, you can't have a line. It must be a ray. So in this case, I'm going to draw a ray. This ray, I'm just going to have it go through point P. Actually, I'm going to have it go through point B for a specific reason. So if I have a ray that divides an angle, so we have one angle, angle XYZ, into two adjacent angles. Once again, we have a building vocabulary. Adjacent angles we learned in the previous unit. So if we have two adjacent angles, here's one angle. Second angle is here. So there's the two adjacent angles. We know they're adjacent because they share a common initial point or vertex and a common side. That side that they share in common is ray YB. That is their common side. So we have adjacent angles. Now what do we have to have? What makes this a bisector? Well, we know that the two adjacent angles are going to be, here's that vocabulary word again that is so essential, they have to be congruent. They have to be the same measure. So in order for us to consider YB, ray YB, a bisector, it must have the two adjacent angles, and in this case it is angle XYB, and I called it B, so we would think bisector. Symbol for congruent, same symbol. If XYB is congruent to angle, my second angle is BYZ. If those two angles are congruent, then I can say that ray YB is an angle bisector. Example number 1. So we have a segment, look at the notation, we know it's a segment based on the notation, is divided by F and G, those are points F and G, in a ratio of 5 to 3 to 2 from left to right. If EH is equal to 30, find FG and name the midpoint of EH. So we have a lot of terminology that is involved with this single question. So let's build it out. Remember, anytime you're given a diagram or must use a diagram, make sure you insert all of the information before you start working. So we know that EH in its entirety is 30. So we know that part of the information. And we're also told that EH is divided by F and G in the ratio of 5 to 3 to 2. Now, anytime you have a ratio in geometry, what we're going to do is we're going to write the ratio in the parts. So 5 to 3 to 2. Now, one other thing is there is a missing component to this, and that missing component is a value that completes the ratio. And in this case, we don't know what that is. Anytime we have a missing value, we assign it a variable, and in this case, I'm going to assign x as my variable. And so, thinking back, again, this is another example of how geometry builds. So thinking back to our segment addition postulate, okay? Segment addition postulate. Thinking back to that. Okay, if you need, go back to the video that relates to segment addition postulate. Rewatch it. Remind yourself. But the segment addition postulate says that if I take the parts of a segment, add them together, it's going to equal the whole. And so in this case, my parts are 5x plus 3x plus 2x, and the whole we've already been given is 30. Combining like terms, all my terms on this left side are alike, so I'm going to end up with 10x, and that will equal 30. I need to isolate the x or get it by itself, so I'll divide by 10, and I have a value of x equals 3. At this point I'm not finished because all I have is my value for x. I need to go back in and substitute that 3 back in for each one of my x values to get the length of the segment. So if I go back, substitute in the 3, okay, so now I end up with 15, 9, and 6 for the lengths of my segment. So now I have a length of 15, 9, and 6, but I'm not finished because I have one more question that I need to answer. Find FG, which I have done, and name the midpoint of EH. So I found FG, that one's checked off. But the midpoint of EH, I still have to find. Well, what does a midpoint do? A midpoint is the middle point of a segment. Well, my segment is EH, and the middle point means it's going to divide that segment into 2 equal parts. Well, this part of the segment we already determined is 15. Okay, that's this value here, 15. The other portion of the segment, this part, is composed of 2 portions, once again, using the segment addition postulate, I can say that 9 plus 6 is also equal to 15. Okay, so here's my 9 and there's my 6. 9 plus 6 is 15. I have two equal segments. For that reason, my midpoint is point F. Midpoint is point F. It divides the segment EH into two congruent segments. Example number 2. Find the midpoints between of 6, 3 and 10, 9. Well, in order to answer this, I'm going to go ahead and give you a little hint. I'm going to move to the next slide and actually give you the midpoint formula. The midpoint formula, similarly to the distance formula, is a given formula that you will have to know how to use. So if these are my x values, and again, these are coordinates, you'll be given coordinates. There's my x values, here is my y values, and all that we are doing is we are going to take the two x coordinates that we're given, okay, let's do it this way. Our two x coordinates, we're going to add them and divide by 2. Our y coordinates, we're going to add our y coordinates and divide by 2. So that your answer is another coordinate, okay? Unlike the distance formula, where you get an answer of 5, a distance of 5, the midpoint formula does not give you a distance. It gives you a coordinate, okay? And this is a coordinate that you can plot on a coordinate plane. So look at the definition now. If x and y, so if we have a coordinate and a second coordinate, and they're endpoints of a line segment, then the midpoint, so the middle point is determined by the midpoint formula. Okay, so you're going to take your x values, add them, divide by 2. You're going to take your y values, add them, divide by 2. You will get a coordinate for your answer. So let's look at this. So if this is my x, and this is an x, and we'll call this x1 and this x2, y1 and y2, the midpoint formula says that I need to have my x values, 6 plus 10, and divided by 2. Okay. And then I'm going to put a comma because that is one coordinate. That will be my x coordinate of the midpoint. I'm going to take my y values, 3 plus 9, divide by 2. So I have an x and a y coordinate. So completing the math, I'm going to have a coordinate as my answer. Well, 6 plus 10 is 16 divided by 2 is 8. 3 plus 9 is 12 divided by 2. 12 divided by 2 is 6. The coordinate 8, 6 is the midpoint. That is the midpoint between, there's the midpoint between these 2 points. Okay, between these 2 coordinates, this one and that one, okay? Example number 3. Point M is the midpoint of segment BC. So we have to draw a diagram. So I have to draw a diagram. I know I have a segment. We're told it's a segment. My segment name is BC. I'm given a point M, and it's the midpoint, so I have to plot it in the middle. So there's point M. And it has, now BC, okay, and has coordinates of 2M. So what that's saying is that point M has coordinates of 2, 4. So my coordinate of M is 2, 4. Point B is located at 610. So I'll write this is 610. And now I need to find the coordinates of point C. I need to find C. How am I going to go about this? It's a little different. I'm still going to use the midpoint formula. However, I'm already given the midpoint. So this 2 is the x-coordinate midpoint. Okay? And the 4 is the y-coordinate midpoint. Now, why do I need to know that? The reason being, when I set up my equation, I know that B, okay, the 6x coordinate 6 of point B is going to be added with some unknown value over here on the C coordinate and then divided by 2 to equal, let's do this. This 6 and an unknown value have to add together divided by 2 to equal 2. So this is what it's going to look like. 6 plus some unknown value divided by 2 has to equal 2. And that is the, and let's see, here's my 6 and my 2. The 2 in the denominator is the 2 that is in the midpoint formula. So completing the math, I have 6 plus a question mark is equal to 4, and I get that 4 by multiplying by 2 on both sides. I now have to subtract 6 from both sides, and my question mark is equal to -2. So the x-coordinate of the C is a -2. Now I have to do the same thing for my y-coordinate. So let's use yellow for the y's. And so what I'm going to say now, I'm going to write it over here just a little bit. I'm going to say that 10 plus a question mark divided by 2 is equal to 4. Here's the 10 and the 4 that are the same and the question mark I'm looking for. Once again, I have to multiply both sides by 2. 10 plus a question mark is equal to 8. Subtract 10 from both sides to get the question mark by itself. And the question mark value is equal to -2. So my point C that I'm looking for, has coordinates of -2, -2. This is using the midpoint formula, but is semi-working backwards in that I'm given the midpoint and I have to find the missing end point, okay? This is an end point. This is an end point. M is my midpoint. And so I'm given a midpoint and an end point, and I have to find the coordinate of the missing C endpoint, which I did right here. This is the missing C coordinate missing C coordinate using the midpoint formula. Okay? Example number 4. Hit pause, see if you can work this. Read the question carefully. Okay? After you've worked it on your own, I'm going to work it now. See how your answer compares to mine. So, look what we're trying to find. We're trying to find the other endpoint because M is a midpoint. This example will be worked the exact same way as example number 3. The numbers will simply be different. Okay? Exact same methodology, different numbers. So I need to draw a diagram. I have a point T. I have another end point that I'm going to call E just to have it as an end point, another end point. In the middle is point M. Coordinate is 2, 0. Coordinate is 6, 2. Don't know. And instead of putting question mark this time, I'm actually going to put an X and a Y coordinate because that's what I'm looking for. So at this point, I know that 6 plus the X coordinate divided by 2 should equal 2. And all I'm saying is 6 plus the X should equal 2, which means that multiplying both sides by 2, 6 plus X equals 4. Subtract 6 from both sides. X once again is -2. Working to solve for the Y coordinate, I know that 2 plus Y divided by 2 should equal 0. Multiplying both sides by 2, I end up with 2 plus Y is equal to 0. Subtract 2 from both sides, and what do you know? We have Y equals -2 once again. So our X coordinate and Y coordinate, and just to color coordinate, here's that 2, here's my 0, here's the Y that I'm looking for. Same Y. And let's X. There are the values of the endpoint E, given one endpoint and a midpoint. Lastly, we have A. I have midpoint M, endpoint E, which we know is going to be an X and a Y, but we don't know what. -4, 3, -1, -1. Using the midpoint formula, once again, to find the X coordinate, I know that -4 plus X divided by 2 should equal -1. That's my X coordinate. And I know that 3 plus Y divided by 2 should equal -1. So here is the X, and Y. Solving using the same methodology, same steps. -4 plus X is equal to -2. Add 4 to both sides. X is equal to 2. 3 plus Y is equal to -2. Subtract 3 from both sides. Y is equal to -5. Okay, I did the math a little bit quicker on those simply because it's the same process as the previous two examples. But what that means is that my coordinate for endpoint E is 2, -5. So there's the -5, which is the endpoint. I guess I should do this as well. And those are my X coordinates that I'm looking for. So once again, please pay close attention as to whether you're solving for the midpoint or if you're solving for the endpoint, what information you're given. Use the distance formula to substitute in appropriately, and then solve using the algebra that you have learned in previous algebra classes. So with that, we're going to conclude this particular unit. If you have questions, please go back, review the information taught in this particular lesson, rework the examples. Anytime you have further questions, please ask a math teacher. We're more than happy to help clarify any questions or concerns that you might have. With that, I hope you have a great afternoon, and we will see you in class.